Welcome to GATE CSE. In this video, we'll solve some previous year GATE questions on the concept of matrices and basics of linear algebra. Let's begin. So they are given a matrix A equal to U into V transform. V is one vector, V transform is another vector. So you find the matrix A as 1, 2 into transpose of V is 1, 1. So A will be multiply this 1, 1, 2 and 2. So find the eigenvalues 1 minus lambda 1, 2 minus 2, 2 minus lambda equal to 0. So 1 minus lambda into 2 minus lambda minus 2 is equal to 0. This is lambda square minus 3 lambda plus 2 minus 2 is equal to 0. So lambda into lambda minus 3 is equal to 0. So lambda equal to 0, 3. Which is the largest value? C. 3 is the answer. If A is Q-symmetric matrix, then A transform is, you already know from the property A transform is minus A. The characteristic polynomial of a 3 cross 3 matrix M over R is this. So characteristic polynomial is always already given. And then one of the eigenvalue of M is 2 already given. So lambda cube means cubic equation. So there will be 3 eigenvalues. One is already given and then they are saying which among these 3 is the largest. Okay. So first we find this A using this lambda equal to 2. So that means your polynomial characteristic equation plus A lambda plus 30 is equal to 0. And then they already given lambda equal to 2. So put it here. 2 cube minus 4 into 4 plus A into 2 plus 30 is equal to 0. 8 minus 16 plus 2A plus 30 is equal to 0. So 2A is equal to minus 8, 22, minus 22. So A equal to minus 11. Now, to find the roots of a cubic equation, when already one root is given, you can use synthetic division. This concept you already learned. Synthetic division. Synthetic division you may have learned in your intermediate or high school. If not, so to solve many of the characteristic equations of polynomials, you may have to find in the exam. So it's better you go through it once. So I will tell you how to solve this when already one root is given. Just write the coefficient of this. So what is the equation now? Lambda cube minus 4 lambda square minus 11 lambda plus 30 is equal to 0. Now, so 2 is already 1 root they are given. So how synthetic division is performed? Write down all the coefficients first. 1, minus 4, minus 11, 30. Okay. Then first you bring on this 1. So 1. And then multiply this root. 2 into 1 is 2. Add to it. It becomes minus 2. Then 2 into minus 2 is minus 4. This becomes minus 15. Minus 15 into 2 is minus 30. Now you get it as 0. This is now quadratic equation. So 1 into, you write it as lambda square minus 2 lambda. And then minus 15 equal to 0. So if I solve this, I get lambda square minus 5, 3 into 5. So 5 into 3 minus 5 lambda plus 2, 3 lambda minus 15 equal to 0. This is lambda into lambda minus 5 plus 3 into lambda minus 5. So this is equal to lambda equal to minus 3 or 5. Okay. So what is the largest absolute values? If I take the absolute value of this, it will be equal to 3 or 5. 5 is the answer. Next, if P equal to this matrix and Q equal to this matrix, then find the rank of P plus Q. So we first perform P plus Q. So this is 0, -1, -2, 8, 9, 10, then 8, 8, and 8. Okay. So find the rank. So go for row echelon form. So I'll try to make this 0. Okay. So this will be R2, R3 is R3 minus R2. 0, -1, -2, 8, 9, 10, 0, -1, -2. If you observe here, these two rows are same. So if I do R3 is again R3 minus R1. So this will become 0, -1, -2, 8, 9, 10, then 0, 0, 0. Okay. Can you further reduce this? So you cannot further reduce this already. It's in the standard echelon form. So echelon form, right? You can make this 0, but you cannot make it because there is a 0 here. So this is the final reduced equation or matrix. So how many linearly independent rows? 2. So rank will be rank of this P plus Q equal to 2. Next, consider system of linear equations Px equal to Q where P is in the real domain. All 3 cross 3 elements belongs to real domain and Q is 3 cross 1 matrix. Now, suppose P has a LU decomposition and written as P equal to L into U where L is given like this. Okay, and then upper triangular matrix is given like this. So this is basically the LU decomposition. So now we pick up which of the following statements is by R true. Okay. Now, A, the system Px equal to Q can be solved first solving Ly equal to Q. So that is what you do. Ly equal to Q. So what is that you have learned? You may solve like this. The matrix is A. Okay. And then you composed into Lu and your matrix B, right? Ax equal to B. This is what you are solving. So instead they have changed this as P, X, and then Q. It is different. So this is true. Then if P is invertible, then both L and U are invertible. That means what? If P is invertible, that is, if P, the determinant of P is not 0, then it is invertible. Then L and U both will be invertible. That is true. If P is singular, then at least one of the diagonal elements of U is 0. What it means? If P is, that is determinant of P is 0, that means one of the diagonal elements here will be 0. This is from the standard property. If you solve any example, you will get that. If P is symmetric, then both L and U are symmetric. It need not be true. Symmetric has nothing to do with LU decomposition. Let L, M, and N be non-singular matrices of order 3 satisfying these equations. So to find determinant of M minus N. So M is L power 8, N is L square. And L square they are given this. So L square equal to L inverse. That means I can write it as L into L square equal to identity matrix is L cube is I. Then M equal to L power 8. Okay. How can I convert this? M is equal to, you can write it as L power 6 into L square. M equal to L into, I can write it as cube into square, right? 3 into 2 is 6 into L square. This M now becomes L cube is I square into L square. So I square is again I only. So I can just write it as L square. So M minus N is equal to L square minus N is already given as L square. So this is equal to 0 matrix. Okay. The determinant of 0 matrix is 0. So given this matrix, 2 cross 2 matrix, which one of the following is A power 8? If you observe all the options here, they are all the diagonal matrix. That means what? You check for whether this is diagonalizable or not. That is A equal to P into P inverse. Okay, so this is diagonalizable. Okay, so what is that I have to find? To find this D. D is nothing but what? It will be lambda 1, 0, 0, lambda 2. Okay, this is how we write the diagonal matrix for this. Now, they are saying A power 8. So let A power 8 is a diagonal matrix. So it becomes lambda power 8 into lambda 2 power 8. So first you find the lambda 1, lambda 2 of this. Okay, then you'll get the answer. So how will you find determinant of 1 minus lambda 2, 2 minus 1 minus lambda equal to 0. So this is 1 minus lambda into lambda plus 1 or lambda plus 1 minus 4 equal to 0. So take out minus common, lambda minus 1 into minus lambda plus 1 minus 4 is equal to 0. So I'll get lambda square minus 1 equal to 4 or lambda square equal to 5. That implies lambda 1 equal to, or lambda is equal to plus or minus square root 5. So lambda 1 is minus square root 5, lambda 2 is plus square root 5. So now lambda 1 to the power 8 is square root of minus 5 to the power 8. So lambda 2 to the power 8 is root of 5 to the power 8. What is this? This is nothing but lambda 1 equal to, it is power 8. So even number minus will become plus. So 5 to the power 4. Lambda 2 is also equal to 5 to the power 4. That is 625. So these are the diagonal elements. This is the correct answer. Next. Let A be a 2 cross 2 matrix given by A equal to 1, 1, 1 minus 1. What are the eigenvalues of matrix A power 13? So same thing. Eigenvalues will be lambda 1 to the power 13 and lambda 2 to the power 13. Find the eigenvalues of this matrix. Now 1 minus lambda 1, 1 minus 1 minus lambda is equal to 0. 1 minus lambda into 1 plus lambda is equal to 0, or lambda minus 1 into minus lambda minus 1 plus 1 equal to 0. Minus 1 minus 1. Now this is lambda square minus 1 plus 1 is equal to 1. So lambda square is equal to 2. Lambda equal to plus or minus square root of 2. What is lambda 1 power 13? Is minus square root of 2 over 13. So you can write it as minus root 2 into 2 power 6. So that is minus 34 root 2. And then lambda 2 power 13 will be plus 64 root 2. This is the answer. Next. Let A be a n cross n matrix for the set of all real numbers R. Let B a matrix obtained from A by swapping two rows. Okay. Now which one of the following is correct? So A and B are same n cross n matrix, but B is obtained from by swapping only two rows. Okay. So we are doing the swapping only once. So the determinant of B is the negative of the determinant of A. Yes. Why? Because when we swap row one time, the sign changes. So initially if it is determinant is say x, Swapping the rows once will make it minus x. Then twice will make again it is minus x. So that is plus x. So it is how it changes. Then if A is invertible, then B is also invertible. That means determinant is not equal to 0 for A, then determinant is also not 0 for B. If A is symmetric, then B is also symmetric. No, we cannot say this. A is symmetric when I transpose, when I interchange that, then the elements may change. So we cannot guarantee always. If the trace of A is 0, then the trace of B is also 0. No, because we are changing the elements. Okay, you are changing some elements in the rows. Swapping the rows means some elements are changed. So the trace may not remain same. Trace is sum of diagonal elements. So if the diagonal element changes, the trace will also change. Next, the product of all eigenvalues of the matrix is. So you find out all the eigenvalues of the matrix. So first try to convert this into a triangular matrix. Then it will be easy to find the product of the diagonal elements. Because they are asking that one only. Product of all eigenvalues is nothing but the determinant of the matrix, right? So you find the determinant. Instead, you just becomes lengthy. Just convert it to upper triangular matrix by row reduction. This is 1, 2, 3. Then try to make this 0. This will be 0. 5 minus 4. So what I am doing here is R2 is R2 minus 4R1. So minus 3. Then minus 6. 7, 8, 9. Then try to reduce this again. You perform R3 is R3 minus 7 R1. This is 1, 2, 3. 0 minus 3 minus 6. Then this will be 0. 8 minus 14 is minus 6. Then 9 minus is minus 12. So again I can reduce this. So R3 is equal to R3 minus 2R2. So this will become 1, 2, 3, 0 minus 3 minus 6, then 0, 0, 0. So the diagonal element is 0. So product of 1 into minus 3 into 0, it is 0. Determinant of this is 0. That is eigenvalues. Product of eigenvalues is 0. Next. Let A be the adjacency matrix of the graph with vertices 1, 2, 3, 4, 5. And lambda 1 to lambda 5 be the 5 eigenvalues of A. And the value of all these is. What is this adjacency matrix? For graph, these are the 5 nodes 1, 2, 3, 4, 5. If I represent it as a matrix 2, 3, 4, 5. Now, see, this is a graph something like this. So 1, 2, 2. That means what? This is a path. Some value x will be here. That is the edge value. But when I say 1 to 1, it's a loop. So I represent in a matrix it as a 0. So all the diagonals will be 0. 0 and 0. That means what? All the diagonal elements are 0. Then all the eigenvalues will also be 0. This is the answer. Next. Let A be a n cross 1 real valued square symmetric matrix of rank 2. Rank 2 already I mentioned with these values. Consider the following statement. One of the eigenvalues must be in minus 5 to 5. The eigenvalue with the largest magnitude must be strictly greater than 5. So when I say rank 2, there may be any number of eigenvalues. So at least 2 eigenvalues will be non-zero. That is the meaning. When I say rank of the matrix is 2, so if there are n eigenvalues, then at least 2 eigenvalues will be non-zero. That is 2 eigenvalues will be non-zero. So how will you write this? This is nothing but I take lambda 1 and lambda 2 are 2 eigenvalues. this equation I can write it as lambda 1 square plus lambda 2 square is equal to 50. That's the meaning. Means this entire a square is converted to lambda square. Now, what is they saying? One eigenvalue must be in minus 5 to 5. Second statement is the eigenvalue with largest magnitude must be strictly greater than 5. So how will you get 50? So let us say lambda 1 is 5 square plus 5 square. This okay, I will get 50. 25 plus 25. But what will happen if the eigenvalue with the largest magnitude must be strictly greater than 5? If something is greater than 5, strictly greater means let us take 6 square. 6 square. Okay. Plus. So what should be the value here to get 6 square? I should get some value something like near to 4. Okay. Near to 4, not 4. Near to 4. Some value. So then I'll get 50. If I make this so, then one eigenvalue must be in minus 5 to 5. So that this will hold. But what happens if, say, if I choose lambda 1 equal to say 5, what will happen now? This will be 25 plus this value cannot be greater than 5. Is lambda square 2 square equal to 25. So that means lambda square cannot be greater than 5. Okay. So lambda 2 cannot be greater than 5. Then it will not work. That is the reason this statement cannot be true. So only one statement is I can get any values in minus 5 to 5 to satisfy this equation. So only one is correct. Next. Suppose that the eigenvalues of matrix A are 1, 2, 4. The determinant of A minus 1 transform is. So how will you find this? Determinant is the product of the eigenvalues. So eigenvalues of A are given. What will be the eigenvalue of A minus 1? A minus 1 and transpose of it. See, eigenvalues will remain same for the transpose. Only thing is calculate A minus 1. So A minus 1 if I calculate, this is nothing but as lambda 1, lambda 2, lambda 3 are given. Okay, and this. Then it is as good as taking lambda 1 minus 1, lambda 2 minus 1, lambda 3 minus 1. So this is 0 into 1 into 3. So determinant is 0 of this matrix. Okay. Two eigenvalues of 3 cross 3 real matrix are 2 plus or minus I. I is a imaginary number. Okay, and 3. So why they are mentioning 2 here? Because 2 plus or minus I is called as a conjugate in the complex numbers. It is a conjugate of each other. So what is the determinant? It's a product of eigenvalues. So 2 plus I, 2 minus I is 2 square minus I square into 3. 4 minus the I is equal to square root of minus 1. If I square it, I'll get it as minus 1 into 3 is 15. Next. The following system has a non-trivial solution. Then which of the following options is true? So just convert this into homogeneous system. They are given P, Q, R, then Q, R, P, R, P, Q. So as a non-trivial solution means what? Determinant of this matrix, whatever form, should be equal to 0. Find the determinant and then check which all should hold. That is P into RQ minus P square minus Q into Q square minus RP plus R into QP minus R square. This should be equal to 0. How will you get this 0? To make this 0, all should be made 0, right? Because it's plus and minus. all should be 0. Now, to make them 0, so this equation has to become 0. So that means what? RQ should be equal to P square. That means what? P is equal to R equal to Q. This is the answer. So P equal to R equal to Q. So that means P plus Q plus R will be also equal to 0. Next. In the given matrix, one of the eigenvalues is 1. The eigenvectors corresponding to the eigenvalue 1 are. Okay, so eigenvalue is already given. To find the eigenvector, that is AB equal to lambda V. What is A? This is this matrix. So 1 minus 1 minus 1 2 0 1 minus 1 0 1 2. This is 1 minus 1 into, let's say the vector is x y z is 0. So what it becomes? 0 minus 1 2 0 0 0 1 2 0, then x y z. So it is equal, that implies minus y equal to minus y plus 2z equal to 0. This is equal to 0. Okay. Then this is x plus 2y equal to 0. So here y implies y equal to 2z. Here x equal to minus 2y. So x is equal to y is 2z minus 4z. So what is my, we put, so z is a free variable here because I don't have anything for. Let us put z equal to t, then, or say they are given it as alpha here, z equal to alpha. What is a vector? This is x is minus 4 alpha, then y is 2 alpha, z is alpha. This is nothing but alpha into minus 4 to 1, and alpha is not equal to 0. So this is the answer. Perform the following operations on the matrix and then find the determinant of the resultant. So here you can do this, just they are wasting your time here. Just observe this matrix and find the determinant. If you observe here, the C3 is nothing but is equal to 15 into 3. That means what? This one column can make it as 0. If one column becomes 0, then determinant is 0. This is the answer. Next. Consider a 2 cross 2 matrix where the eigenvalues are minus 1 and 7. The eigenvalues of A and B are. The values of A and B are asking. So how will you find this? So they are given determinant equal to product of the eigenvalues. So determinant is A minus 4B equal to minus 7. So put the values here and check it. Otherwise you can solve it. Options are given. You have to get minus 7. So A is 6. 6 minus 16 no. 4 minus 24 no. 3 minus 15 no. 5 minus 12 is minus 7. So this is the answer. Value decomposition of the matrix. If the diagonal elements of U are both 1, then the diagonal entry I22 of L is C. The standard LU decomposition, what we do is, the lower triangular matrix, this is upper triangular. So we will make this element 0. Some x, y, z elements will put it here. In the lower triangular, what we make? The diagonal elements will make 1, this is 0, and some value, say A here. This is the standard approach. But what they are saying, they are asking you to make one here. Okay. So what they are asking is it should be something like this. They are saying, and L can be some value here, and then X, or say XY, whatever it may be. So 0 here. This is what they're forming. So just they're asking you to reverse the approach. So what is that you have to find? They're asking you to find this element, means this element. So how will you find? You perform the row operations to make this element 0. Then definitely you get your answer. So no need to follow LU decomposition procedure. So how will you make this? Let us take 2, 2 and 4, 9. So how will you find this? Make this element 0. So to make this element 0, you subtract column 2 minus column 1. So this will be column echelon form, applying column echelon form, but I am not converting to column echelon form. So this becomes 0, this becomes 5. This is my lower triangular matrix. So this element is 5. 5 is the answer. Next. The rank of the matrix A is equal to. So check for any rows which are similar. So let us try to reduce this matrix to upper triangular form. So 1, 9, 1, 2, 1, minus 1. Then 9, 5, 2, 2. I perform R3 is R3 minus 7 R1. So this becomes 0. 1 minus 14 minus 13. Then 0 minus 7 minus 7. Then 4 minus plus 7. So 11. Okay. Now try to make this element 0. This will be R2 is R2 minus 9 R1. This is 1, 2, 1 minus 1. So this becomes 0. 5 minus 9. 5 minus minus 13. Then 2 minus 9. Right? 2 minus 9 is minus 7. Then 2 minus 9 plus 9. So this is 9, 11. And then I have 0 minus 13 minus 7, 11. So you subtract R3 from R2. The last row becomes 0. 1, 2, 1 minus 1. 0 minus 13 minus 7, 11. So 0, 0, 0, 0. That means what? So the rank of this is 2. This is already in row echelon form, so I cannot further reduce it. So rank will be equal to 2. Next. Let A be a square matrix of size n cross n. Consider the following pseudocode. P equal to 100 for I equal to 1 to n cross n matrix. Then for the inner loop to n, temp equal to A of ij plus some c. Okay, c equal to 100. Then inside this only they are doing swapping here, equal to A of ji. Then A of ji is equal to this temp minus c. So that is this cancels, equal to temp. So then they are printing these values. See what they are doing here. Ij, they are making it ji. So that means what? It is transpose of A. That's it. This plus c minus c that gets cancelled no, here. So this is, they are doing minus c here. So this C cancels. Just they are swapping the elements. That is, they are finding the transpose of the matrix. If V1 and V2 are 4-dimensional subspaces of 6-dimensional vector space V, then the smallest possible dimension of V1, V2 is. Okay, so this is not at all a vector problem. The only thing is it's just an aptitude question. Pn and V2 are 4-dimensional subspaces. Okay, 6-dimensional vector space V. Okay, the dimension of vector space V is equal to 6. And V1, V2, dimensions of V1, V2 is 4. They are the subspace. This is subspace. This is the entire vector space. Okay. Possible dimension, that means what? I have V1, V2, V3, V4, V5, V6. This is entire space. Entire space, vector space. In that I have taken 2. Okay, 2. Let us write it as dash like this. Now V1 should be 4. I have to choose 4 among them. V2 I have to choose 4 among them. Okay. You choose first 4. Then V2 will be some other 4. At any point of time, 2 vectors from this will be same. That is intersection is equal to 2. Dimension 2. So answer is 2. To take any order. So I have to take 4 here. No, 4. 4 vectors here, 4 vectors here. Out of 6 vectors. So 2 will be repeated. That is the intersection value. Which of the following statement is true about every n cross n matrix with only real eigenvalues? Okay. So they are mentioning the eigenvalues are real, not complex. Next. What is that? If the trace of the matrix is positive and then the determinant of the matrix is negative, at least one of the eigenvalues is negative. Means what? Lambda 1 plus lambda 2 is equal to plus lambda n is equal to trace. This trace has to be positive. Okay. So this is positive. The determinant of the matrix is negative. So lambda 1, lambda 2 up to lambda n is equal to negative. Then at least one of its eigenvalues is negative. This is true. Okay. The determinant will be negative only if there is at least one negative value. So if there are 2 negative values, then it is positive. But the trace, cannot say about the trace, right? So for the determinant to be negative value, one of the eigenvalue should be negative. If one of the eigenvalue is not negative, then the the determinant is not negative. That is the thing here. If the trace of the matrix is positive, all its eigenvalues are positive. It need not be true. For example, lambda is say minus 10 and lambda 1 is 20. If I add them, I will get it as positive only. This is not true. The determinant of the matrix is positive. All its eigenvalues are positive. Need not be true. I can have minus 1, minus 10, minus 10. It is plus only. If the product of the trace and determinant of the matrix is 0, trace and all its eigenvalues are positive, doesn't mean. So eigenvalues can be negative. I will get the positive trace, positive determinant D. I will get the positive trace also. So need not be true. Only A is true. The product of the non-zero eigenvalues of the matrix. So the very big matrix they are given. They are asking you to find the product of non-zero eigenvalues of the matrix. For such things, you first try to find the rank of the matrix. Now, if you see here, if I subtract these two, it becomes 0. Again, this and this is 0. And this 0. So, effectively, there are only 2 rows left in this. Only 2 rows left in this. So, the rank of this is equal to 2. The rank is equal to 2. So, lambda 1 equal to, this is one rank, this is another rank. Okay, 1, 1. Now, lambda 1 will be equal to the sum of this values in that matrix. Sum of equal to 1 plus 1, this is equal to 2. Then lambda 2 is equal to 1 plus 1 plus 1 is equal to 3. That is the properties from the rank and the eigenvalues. You already learned it. So this is 2. The product of this is 2 into 3 is 6. The value of the dot product of the eigenvectors corresponding to any pair of different eigenvalues of 4 cross 4 symmetric positive definite matrix is. A 4 cross 4 symmetric positive definite matrix is an orthogonal matrix. The definition itself you can see it's an orthogonal matrix. So for the orthogonal matrix, the length of the column vector is equal to 1 and the dot product between the vectors, between any two vectors is 0. So dot product of eigenvectors is 0. Next, consider the following system of linear equations. The number of solutions for the system is. So find the augmented matrix in the coefficient matrix 3, 2, 0, 1, 4, 0, 7, 1, 1, 1, 1, 3, 1, minus 2, 7, 0. Okay. So what first you check the consistency, that is rank of coefficient matrix is equal to rank of the augmented matrix, entire matrix. So try to make this 1, because to observe here this, to subtract here this, I can match this row easily. So I will perform R2 is R2 minus R1, 3, 2, 0, 1. This is 4 minus 3, 1, 0 minus 2, minus 2, 0 minus 7, minus 7, and then, sorry, 7 minus 0, 7. This becomes 0. Then I have 1, 1, 1, 3, 1 minus 2, 7, 0. Okay. So now, to observe here, if I subtract these two rows, I'll get one row as 0. So 3, 2, 0 is 1. 1 minus 2, 7, 0. 1, 1, 1, 3. So I'll perform R4 is R4 minus R2. So this will become 0, 0, 0, and 0. So if we try to further reduce it, I can make it this 0, but it will still be there. So try further reduction is not possible. So rank of A is equal to rank of augmented matrix is equal to R, that is equal to 3, because we get 3 independently linear rows. So that means what this system is consistent. We can find the solution. How many solutions are possible? Rank equal to 3 is equal to number of columns. What is number of columns here? X, Y, Z, right? 3 variables. So n is equal to 3. This is 3 is equal to n. So therefore there is a unique solution. Unique solution means answer is 1. Only one solution is possible. Next. What is a matrix transformation which takes the independent vectors 1, 2 and 2, 5 and transforms them to 1, 1 and 3, 2 respectively? Asking, if I apply a matrix A onto V, I will get another transformed matrix, say VT. What is this A they are asking? So simple, you form the matrix using these vectors. What is the matrix? This is 1, 2 initial matrix. Okay, and then let's say this as V matrix, or write P matrix 1, 2, and then 2, 5. And then this is transformed matrix. Q is becomes 1, 1, 3. So what it means? A into P is equal to Q. So A is equal to Q into P inverse. Right? So you find the inverse of P. So P inverse is equal to determinant of P is 5 minus 4 1 by 1 into you change the elements and change the signs of these two minus 2 minus 2. Now we multiply Q 1 3 1 2 into 5 minus 2 minus 2 1. This will become 5 into minus 3. Next, let A be 2 cross 2 matrix with elements A11 equal to A12 equal to A21 equal to plus 1, and so what they are saying, this is 1 1 1 and minus 1. And the eigenvalues of A power 19. So eigenvalues of A power, first find the lambda value for this. So 1 minus lambda 1 1 minus 1 minus lambda equal to 0. This is 1 minus lambda into minus of 1 lambda plus 1 minus 1 equal to 0. It is lambda square minus 1 equal to 1. Lambda equal to plus or minus square root of 2. Then A power 19 is lambda 1 power 19 is minus root 2 the power 19. Then lambda 2 power 19 equal to square root of 2 power 19. So this will be minus root 2 into 2 power 18 by 2 is 9. Will be root 2 2 power 9. This will be root 2 minus root 2 into 2 power 9 is 512. Will be equal to root 2 into 512. Let A equal to this and B is equal to this. Let A and B denote the determinants of the matrices A and B respectively. Which of the following options below is true? If you observe carefully here, 1, 2, 3, 1, 2, 3, 4, these two rows are same in both the matrices. And these two rows are same. Only thing is you have to swap this. Swapping this will change the sign of the determinant. If determinant is A, after swapping, it becomes minus determinant of A. So, for determinant of B. It means what? If it is determinant of A, both will have the same determinant. Because I swapped it only once, the sign changes. So, this will be determinant of minus A. Next, which of the following is by are the eigenvectors of the matrix? Okay, this is, you have to find the first eigenvalues and then perform A V equal to lambda V. This is very lengthy procedure. You have to check all, find all the vectors and then check which of them are there. First, you have to find all the eigenvalues. It is a 4 cross 4 matrix. So it will be difficult or lengthy. So what you can do is, without finding the lambda value, you just check, multiply this each vector to the row and then check whether I am getting in this lambda into V form. Means some constant into or some scalar into that this vector. Then that will be the vector for this matrix. Okay, I will show one example. Even though you can do it like this, but it is still lengthy because I have to check for all the 4 vectors. I will show it for one vector, then you can solve it like that. But in the exam, please make sure that if you are not able to find this in the time, then you can keep it for the last. This is my suggestion. So what is that you have to do? How will I check this? See, take this first row, okay, and then multiply this minus 9 minus 1 into minus 9, then plus 1 into minus 6, then plus 0 into minus 2, plus 1 into minus 4. And then for similarly for second row is 1 into minus 8 plus 1 into minus 6 plus 0 into minus 3 plus 1 into minus 1. Okay, similarly, you go on doing for 4 rows. For that is for the first option. Like this, you have to do it for all A, B, C, D. How will you verify? If I add this is 9 minus 6 minus 4. So this is minus 1. And this here is minus 8 minus 14. And then minus 1. So minus 15. Okay. So here it is minus minus plus. Okay, I missed it. So here this will be 1. If you observe here, I will get 0 here because all zeros are here. Then I have 1 here. You get as 1. This is C. Again, I am getting back the same vector. So similarly, check for all. So what is that I am saying? I may get something like, say, for example, not only this, directly I got it minus 1, 0, 1. So into some constant. Here constant is 1. That is my lambda value. For eigenvalue equal to 1, I will get this. There is a lambda equal to 1 for this. Suppose I may get something like this minus 3, 3, 0, and 3. This is also a vector. That is what? Take out 3 common. Minus 1, 1, 0, 1. So for lambda equal to 3, this is the eigenvalue. So for all the matrices, for all the vectors here, you check like this. In whichever form you get like this, okay, with this matrix, minus 1, 0, 2, 2 into some lambda. If I get that, then that will be the eigenvector for this. So it's a very lengthy problem. So you can solve it. You can just try it. So if I want, I can give the answer A, C, and D are the correct. This will not get correctly. Okay. Next, consider solving system of simultaneous equations using LU decomposition. So they are given 3 equations and LU are given. So unlike previous question on this, they have not mentioned that where are the ones. So I will go for the standard approach. What is standard approach? So this is 1, 1 minus 2. Get the coefficient matrix 3 minus 1, then 2, 1 minus 5. Okay. Now, to convert it into upper triangular matrix, apply row echelon forms. So try to make these elements 0. So, and now note down this multipliers. R3 is R2, R3 minus 2R1. So this will be 1, 1 minus 2, 1, 3 minus 1, then 0, 1 minus 2 is minus 1, then minus 5, 4. So this is plus 1. Now this matrix, so you try to make this 0. That is R2 is R2 minus R1. It is 1 R1. 1, 1 minus 2, 0, 2, 1, 0 minus 1, 1. Now I want to make this also 0, right? How will I make? So if I add this, so how will I add? R3 is R3 minus plus 1 by 2 R2, right? So 1 by 2 into 2 is 1. Subtract, get 0 there. So this will become 1, 1 minus 2, 0, 2, 1, and then I have 0, 0. So this will become 1 by 1 minus 1 by 2, that is 1 by 2. Okay. Next. So this is my quadrangular matrix. Now, how will I do it? Here it is minus 5 plus 4 is minus 1. Okay, this is minus 1. This will be minus 1 by 2. Next, what will be my lower triangular matrix? Lower triangular matrix is 1 0 0 1 0 0 1. So I have to find this. What is that they are asking? L32. L32. Okay. So L32, this value they are asking 3 column 2. So L32 I will find. How did I get 0 here? I got 0 by doing what? By adding this R3 plus 1 by 2 R2. So when you write this L32 the multiplier, I'll change this sign. I explained this concept in my videos how to do it. So this is minus 1 by 2. Using this multiplier, I got this minus 1 by 2. Then what is U33? U33 is this value. This is minus 1 by 2. So U33 is equal to minus 1 by 2. Okay. So we find now the x1 value. So check any other options. No other option is matching this. So even if you don't find x1, then it is the correct answer. So we'll solve few more problems, GATE PYQs in the next video. Thank you for watching. Please like, subscribe and share.